Hello and welcome. Today we continue with our discussion on the reactions of aldehydes and ketones with various nucleophiles, and this is presented to you by Science Visualized. Aldehydes and ketones who react with hydroxyl nucleophiles OH minus, you end up adding the OH minus to the carbonyl carbon, and this carbonyl is reduced to alcohol. So in this case where you have two OH, that's called a hydrate. And hydrates basically reacts just like aldehydes and ketones. In this case, this is a ketone, so this hydrate will react like a ketone. If the hydrate is made from an aldehyde, then it will react as an aldehyde. The other thing that can affect this reaction is addition of water. So HOH, that's a neutral nucleophile. And then when you add a neutral nucleophile, you lose the hydrogen and you only add the OH. So you still end up with the OH added. Next, reaction with sodium cyanide. And this could be sodium cyanide, potassium cyanide, lithium cyanide. All of them will give the Cn minus nucleophile. And the way you write it, the minus charge is on carbon. And then you have triple bond to nitrogen. So that's a cyanide ion. Under neutral and acidic conditions, you react with HCN, hydrogen cyanide, and that will still affect the same transformation, where the carbonyl is changed to an alcohol, but now you end up adding the cyanide nucleophile. Next, reaction with alkyl magnesium chloride, and that's the Grignard reagent. But you can also use other types of organometallic reagents like alkyl lithium or cuprate reagent, dialkyl copper lithium. All of them will give the R minus nucleophile. And as we mentioned, the carbonyl is reduced to an alcohol, and then now you end up adding the nucleophile, which in this case is going to be an alkyl group. So for example, if you use a CH3 MgCl, then instead of that R, you end up adding the CH3 because the nucleophile here is CH3 minus. If you use MgBr, the nucleophile for that is you cut this carbon-magnesium bond, and that carbon is going to have a minus charge. So you end up adding that as the alkyl group. Has 1, 2, 3, and 4 carbons. Next, reaction with reducing agents. Reducing agents give H minus nucleophile. In this case, we're using sodium borohydride. So just as we saw before, the carbonyl is reduced to an alcohol, and then you end up adding the nucleophile, which in this case is H. So basically, you reduce an aldehyde or ketone to an alcohol. Other types of hydride nucleophiles, also called reducing agents, are borane, BH3, sodium borohydride, Dibal, diisobutyl aluminum hydride, lithium aluminum hydride, also called LAH. So all this will give H minus nucleophile. Stay tuned for the next part. We're going to look at the reaction with amines. Thank you for your time. Please subscribe and like this video.